Hello everyone, here is a simple question and it's a single choice correct question. So requesting you to pause the video here and please post your opinion in the comment box. I'm starting the solution on the board. Here we have a positively charged non-conducting sheet. Sheet is taken to be infinitely large. There is a point charge minus q having mass m. It has to be projected in such a manner that it returns back to its initial position. Okay. So to start the calculation, first of all, we'll draw the free body diagram. On this mass, the gravitational force will be like this, and this negatively charged particle will be attracted by the positively charged sheet. So it will have the electric force in this direction. The electric force will have the magnitude QE. Got it? We already know that F vector is equal to Q times E vector, and due to this sheet, the electric field will be in this direction. So if Q is negative, then the force on the charged particle will be in the opposite direction of the electric field. Got it? Now, suppose the resultant of these two forces is like this, just opposite to the initial velocity vector. If F net is like this, then how will be the motion of this charged particle? Velocity is in this direction, net force is in this direction, means the acceleration is in the opposite direction of the initial velocity. So what will happen to this particle? It will be going like this and slowing down. At some moment its speed will become 0 and then it will return back to its initial position, like as we do in this case. A ball of mass m is projected up with the speed u and acceleration due to gravity is in downward direction. Then what happens to the speed of the ball? It decreases. At some point velocity becomes 0 momentarily, and after that it crosses back the initial position. Same thing is happening here. It is projected in this direction. Initially it will slow down, will attain momentarily rest position, and then it will return back. Got it? So if this angle is theta, this angle should also be theta. Now we can consider a triangle. Here is the net force in this direction, the gravitational pull is in this direction mg, and the electric force QE was in this direction. Angle here has been taken as theta, and this angle is also theta. Do you agree? In this triangle, this one, in this triangle we are taking up the tan theta. So what will be tan theta? It will be equal to mg by QE, and we know the magnitude of the electric field. This electric field is having the magnitude sigma by 2 epsilon naught, because it is a non-conducting sheet. I hope you remember that expression. So the theta will be equal to what? Tan inverse of mg 2 epsilon naught q sigma. I hope you have also chosen the correct answer. Few of you might think, why we have chosen this possibility only? Why not the particle is going on some circular path or some parabolic path? I am explaining those things. Suppose the particle is projected from this position, initial velocity is u in this direction, and instead of taking force along the blue line, suppose I consider this red force here like this. So if this is the force on the particle, how will be the path of the particle? Obviously it will be parabolic. If it is parabolic trajectory, will it ever return back to its initial projection point? Not possible. So we have not taken the net force along the red direction. Got it? You have seen that if this is mass m thrown like this, acceleration due to gravity is here, it performs the projectile motion, then it will never ever return back to its initial position. So this is obviously not a choice. For circular motion of this particle, one component of the force must always be acting toward the center. And here in our question, the net force is always constant. because mg is constant, q is constant, so the net force has a fixed direction. And for circular motion, at least there should be one force which is always acting toward the center, means the force must be changing its direction also. This force cannot do that thing, so particle cannot perform circular motion, cannot perform the projectile motion. So the simplest and the only possibility is this: it performs the rectilinear motion, goes there, stops momentarily, and then returns back like this ball does. Got it? Simple and nice question. I hope you enjoyed it. Stay awesome. See you again.